Okay, so to resume where we started off when we stopped. So that means, all that means is that our acceleration has to be directly opposing it, which means that there has to be, what we talked about earlier. Why is there a negative 9.8 meters per second squared? That's because, excuse me, we have the force in the opposing direction, right? Why do we have gravitational constant? It's because we have gravitational force. Where there's a force, there's an acceleration, right? That's what's causing there to be acceleration. So there's an acceleration to the left. That means we had to have a force to the left. And this is just a force. It could be anything: force friction, force air resistance, anything that factors in to this car slowing down. Okay, so that's the answer. So now we're starting to the meat of these problems, which is how to solve them and how to break them down. Okay, so let me go pull up my notes because make sure I remember how to solve this too. All right, so let's start off. I need to eat, so let me make sure I finish this effectively, efficiently, and everything. So a block slides down a frictionless plane having an inclination of 15 degrees. 15 degrees. The block starts from rest, forward at the top, and the length of the incline, forward, is 2 meters. So we need to draw a free body diagram, find the block's acceleration, and find its speed at the bottom of the incline. Got lots of things going on. So let's start off by drawing a picture of what's happening. We got a block on an incline. Okay. This is our block. Or I don't know, that was an old name. So we're told that this incline is 2 meters in length. We don't know why that's relevant. We're just gonna, suck it up for now. We're told that this is 15 degrees. That's the inclination of the plane. And we're asked to draw a free body diagram. So let's get started. So first, we're gonna think about this block. Think about everything I told you earlier about that sphere on a slope, right? We need to be able to draw a free body diagram that is adjusted like that on this axis, right? So what do we know about this block? We know that it's on some kind of surface, indicating that there is normal force going up. We also know that since we're on Earth, we have gravity. And since you're just drawing a free body diagram, you can just draw force gravity. You'd be set. That'd be the answer. You'd get points. However, I want y'all to think about it a little bit more because think about the next steps. This is not enough for your next steps. To start your next steps, you have to split up. Let me go download this. You have to split it up. Split this gravitational constant up into X and Y. So I'm going to go yeet all the way down to the bottom over here. I say yeet a lot. I don't know why. So here's a free body diagram. We're going to now do an advanced free body diagram that we'd have to do anyway to solve the problem, right? Force normal is our constant. It's steady. It's a steady boyfriend. It's going well, okay? Normal force is always going to be fine. It's gravity that always screws us up, screws us over again and again, okay? And so we know that our gravitational is this. But we aren't happy with that. Because it doesn't fit, guys. It doesn't fit. Look at this. Does it look like it fits? No, right? It's crappy drawn, but point is, it doesn't fit. We gotta split it up. So we gotta do, so we split it up to X and Y. So we think about it, right? FG. Then we think about it. That is splitting it up. We got our force gravity, Y. This is Y. This is X. I'm wasting time. Who cares? Okay. X. FGX. Okay. And we have our little angle right here. Guys, like a confusion of this angle every time. Just remember, if you ever have questions about this angle where it's at, it's going to be the angle between, think about your force normal. I'm going to follow it with my highlighter. It's going to be going from your force normal and down. Just go down. And that angle is going to be to your gravity. Okay. You don't get it if you haven't done it in practice. So, once you do a practice, you'll understand what I'm saying. Like, why is that angle always, it's kind of tentative, like, where is it, right? Just think of it going down, force normal, and then going the angle to, and then it's angled out from that that y component to your gravitational component. That's the angle. It's always going to be like right here and right here. Okay. Kind of how you think about it. Okay. So I want to simplify this because it's a little confusing for us. So I'm going to simplify it a little bit more. You have Fn, you have Fgy, and we have Fgx. Remember, we don't have this anymore because we split it up. So we're happy now. Okay. What this first appearance, this A, what I'm gonna call A, is important for, is being able to see where the angle goes, right? Because what we need to do is, remember, we need to be able to solve for what is Fgx, what is Fgy. And to do this, we have to use that angle that we have. So we know that, we actually don't know. We actually don't know. Okay. This is a challenging question. I always pick the most challenging questions. I'm annoyed at myself. Okay, Fgy. We know that this is Fg. We know Fgy, like we were saying earlier, right? Fgy, sine, use sine. Why the heck? No, don't use sine. Don't always use sine. Look, Fgy, we're trying to find this angle right here. We know this is our hypotenuse. All right. How do we solve for this? If we're given this value right here, Fg, you use Fg, you can use W, same thing. Fg is equal to M times G, W is equal to M times G, same thing, okay? We know that this is going to be Fg, and then think about this angle. We want this side right here. We have this side, so we have hypotenuse. We have our adjacent angle. Hypotenuse adjacent, we use cosine. Fg cosine, our angle, 15. That means this is just going to be the opposite. Fg sine 15, okay? Okay, that was confusing. I'm sorry. This is like the most disorganized I've been for this problem. I hate doing forced problems. My brain just thinks different from the way I need to present it. So what I'm going to do is solve. We solve for A. Good. Now we need to find the Bloch's acceleration. Acceleration has to be found in the way that it's moving. It's not moving this way. It's not moving this way. No. It's moving this way. So we're going to be finding acceleration, but only with the things in that direction. So we're only going to be looking at that. Only going to be looking at the X, the alternated, the change X-axis. Okay. So that means all we got to do is do the net, the sum of forces in the X direction, adjusted X direction, is equal to Newton's second law, mass times acceleration in that X direction. What makes this problem challenging is we have no mass of the block, but I'm going to show you how to break this problem down. This is the most challenging derivation of this problem you can receive. Hopefully you'll understand where we're getting the numbers from. And it's challenging because you aren't given a mass. You have to figure out how to go through this little equation until you have enough numbers and only one unknown variable. Right now you have two unknown variables. You have your mass that's unknown. You have your acceleration that's unknown. I'm going to show you how to break it down, okay? Look at all the forces in the X direction. There's only one. It's Fgx. Fgx is equal to max. That's not any more helpful. What is Fgx? Fgx, as we know from here, is Fg. Fg sine 15 degrees is equal to max. Okay, we're doing a little better, right? But still, two unknowns. We don't know Fg. We don't know m. We don't know the x. Now, I'm going to ask you, what is Fg? And if you go up here, you see the Fg is equal to m times g. M times g times sine 15 is equal to m times ax. Okay, now we're talking, right? We have two of the same variables on either side. So if I divide by m on both sides, I cancel out my m's. What I got now is a few less unknowns. G sine 15 is equal to ax. Are you telling me, Trey, there's still two unknowns? How do I solve for this? It's not two unknowns. You know what G is. You've been dealing with G for an entire semester by this point, okay? G is 9.8. Remember, it's not A. A is, if you're talking about any A in the Y direction, it's negative 9.8. We're talking about G. G is always going to be equal to 9.8, positive 9.8 meters per second squared. Okay. Keep that in mind. Give a second. Meters per second squared. So 9.8 sine 15 is going to give you an answer of the acceleration. You're going to get 2.54 meters per second squared. Okay. That's how you're going to get there. So I think that's personally a little bit easier. It's just, this is a particularly challenging question where they don't give you that mass. So it's a little bit more challenging, okay? You can solve this. I think you can solve anything. Next, we're going to find its speed at the bottom of the incline. Speed at the bottom of the incline. You don't remember how to do this? Let me review my notes. So we're asked to find speed. That means we're going to have some kind of kinematics, right? We're going to pull in chapter 3, everything we've been talking about. So what do we do with when we come to a chapter 3 problem? We list what we know and what we don't know. So I want you to look back at this question. All right. So we used what we knew. We used 15 degrees. We saw frictionless. There's no opposing force, right? We started, but there's kind of information that the problem gives us that we haven't used yet. And I'm gonna highlight them for you. So it starts from rest and that the length of the incline is 2 meters. Now in my head, this puzzle, right? There's pieces that I haven't put down yet. That means I'm gonna have to use it for this last part of the problem. So we know that it starts from rest, 0 meters per second. We're told the length of the incline is 2 meters. You know what the length of the incline is. You know length, 2 meters, change in x, okay? And don't forget, you know what acceleration is now in the x direction, specifically acceleration in the x direction right here. AX is equal to 2.54 meters per second squared. Squared. Now we're asked to find what is the final velocity. Okay, so look at your kinematics table. How does it work out? Final velocity times the square is equal to the initial squared plus 2ax. Plug and chug. You just gotta plug and chug now, okay? 2. What am I yapping about? Yapping about nothing as well. This goes to 0 because it's 0 meters per second. You have 2 times 2.54 times 2 is equal to v final squared. How do we get there? Square root both of it. Get v final is equal to square root of 10.16 meters squared over second squared. And v final is going to be equal to 3.19 meters per second. So we're pulling it all together. Okay. So next question, because the questions keep coming because I put on way too many for this review. It's already 7:01 and we die. Okay. A boy pulls a 50 kilogram crate at a constant velocity across a rough floor. Rough floor should send ding dings off in your head, telling you that there's friction of some kind. You're going to have to count that into your free body diagram, into your problem solving. Okay. Oh, my cheeks look so shiny and beautiful. Slide. Okay, so let's go highlight what the information we have. 50-gram cart is pulling, could be useful, with the force 200 newtons. And the force acting on the crate at an angle of 30 degrees above the horizontal, taken to note, very important. And the coefficient of kinetic friction is 0.3. Determine A, the normal force exerted by the crate on the floor. So you know me, what I gotta do is I have to draw a picture first. I have to write down what I know first. I'm gonna draw this picture, okay? Let me think about it. I have the floor, I have the crates, just draw a beautiful box. And I'm being told that he's pulling, there's basically, let me think about it. He's not pulling anything. What is he yapping about? Okay, ignore the pull. He's freaking pushing. Push, guys, push. Doesn't make sense to me if he's pulling. Guys, he's pushing, okay. So we're told that a force of 55 newtons. Uh, Give me a second, pause. My answer key is wrong. Let me go back. What, did I skip a question? What the heck? Did I just not have a question? Okay, I don't know what's up. Pools. Oh, what the heck is this question? Give me a second, I'm gonna pause. Okay, that was a mess of a question because I somehow skipped the fact that I included this. Okay, because I don't want to figure it out right now, and because we're short for time already, I'm just gonna tell you if you want to do this for extra practice, you can Google it, probably the answer's out there somewhere and worked out. I'm just gonna move on at this point to the next question that I do have keyed. I'm gonna write down extra practice for you if you want to do this. Extra practice. That does not make me feel like doing a smiley face, and it works in this case. Answer key's out there somewhere, okay? I'm trying to get the stuff so I can go. But all right, let's just skip to, I'm sorry, and everything I said before is messed up because I thought I was doing this problem right here when I was doing the other problem. And I guess I added stuff over the last 2 years, over the last year or so. Okay, anyways, let's move on. Worker pulls a 20 kilogram packing crate at a constant velocity. That's important. Across a rough floor. That's also important. Rough floor is important. Force of 55 newtons is being applied to the crate at an angle of 35 degrees below the horizontal. That will help us set things up. First thing we need to do is draw the fault free body diagram. And how we do that, we gotta visualize the situation first. Just think about this. This is your crate. You are, they say pulled, but it's being applied. And so 35 degrees below the horizontal. Okay, assume this is the horizontal. Hell, assume this is the horizontal. Angle of 35 degrees below the horizontal means that you're going from this horizontal fake line to 35 degrees below it, okay? So this is 35 degrees right here, and this is the force you're pushing at 55. You are pushing or pulling, I'm saying pushing because I don't know why you'd be pulling. 55 newtons, okay, pushing. Maybe there's a reason to the madness, but I don't really understand what's happening. So I'm gonna clarify this in a free body diagram for part A, which is that's kind of what's happening, right? But think about this crate that's sitting on a surface. You have normal force, of course, acting on it. You have gravity force, which is nice and easy because think about this force, this crate, right? If you're pushing it, it's moving. Think about anytime you're pushing a crate. It's moving that way. It's not moving like this. You're not pushing it. You're just pushing it that way. Even depends if you're pushing at an angle, you're still pushing it that way. So there is no motion up and down. So we're gonna figure out what that means later, right? But that means that there's gonna be motion in X because things are changing, things are moving. So we're told there's a rough floor. Rough floor just means that there's friction force. I'm gonna assume that everything is going right, okay? Right motion. You're gonna assume it's left, just adjust for it, which means that there's friction force going to my left, since I'm assuming this is going to the right. Now I'm gonna have to counter this push force. This push force, as we said, though, doesn't fit. Look at this push force. It does not look nice. It's not what we like. because if you look at it, we're looking for something like this. Push force is going at an angle like this. It doesn't fit into what we want in our idea, our axes, right? So what we got to do is make it fit. So push force is like this. Our F push force. We want to take it fit. We got to split it up into its components, which is F push. I'm gonna put FP X, and I'm gonna do FP Y. Okay. And I know that this angle between this horizontal is 35 degrees. Okay. So that means I know that FPX is going to be equal to F push. Here, I'll make it clearer so that you can kind of see where F push is. FP, right? So FPX is going to be equal to F push. We're told that F push is equal to 55 newtons. So that means, remember what I said before? It's going to be equal to A, depending on what it is, cosine or sine, right? Just look at your text. Okay, so this is 55. This is going to be our adjacent. This is our hypotenuse. So we use cosine. It's AH, cos, right? Cosine 35, which means that this is 55 sine 35. Okay. So this is ew. This is too much information in one graph. I'm going to put it into a nice clean free body diagram. For y, we make it as y as we want. We have force friction. We have force normal. We have force gravity. We have another force push y. And we have force push x. Okay, that's our free body diagram. On the exam, she really only wants to see you just draw this, and this. But for the sake of your own problem solving, you're better off drawing everything. Unless you can easily do it without visualizing, then you don't need to do it. But very few people, I think, could do that. So don't worry about it. So we're actually going to get to solving this problem, which is asking what is the force of friction between the crate and the floor? Okay, let's think about it. Force of friction between the crate and floor. Force and friction. Where is force and friction on this axis? Friction is on the x-axis. Oops, I erased it. That means if I want to solve this problem B, I need to think this way. Okay. So that means I need to think only about motion in the x. And I need to think about F nets. So we know sum of F nets, F net in the x direction, is equal to ma by Newton's second law. Okay. So think about F net, it's just sum of forces. Remember, we take positive, subtract, and then plus negative, okay? That means F push x, F push x minus F is equal to max. Get this positive, subtract this, okay? Right from left, right is your positive, left is your negative. What you're going to be left, of course, is you do this mass of 20 kilograms times an acceleration. Is there an acceleration? So I'm going to ask you next. Look at there. Is there an acceleration? It says constant velocity. No acceleration. So times 0, everything goes to 0. Okay. What we're going to have is FPX minus FF is equal to 0. Now, if I add FF, right, to get rid of the negative, what I get is FPX is equal to FF. That means this X value right here is equal to that. So you're asking me, oh, what do I do next, right? I know what FPX is. If I look here, I got it right here with me. All I got to do is plug into my calculator and solve for it. Once again, a lot of front loading, but once you front load it, it's easy, right? 55 cosine 35 is going to be equal to your force friction. And that is your solution, ladies and gents. Okay. Moving on to the C, what is the coefficient of kinetic friction on the floor? This is nothing complicated. At least I don't believe. Actually, oh my gosh, it is complicated. I lied to you. I'm sorry. Okay, let's think about it again. Let's redraw our revised diagram. I lied. This is complicated. Okay, so we know our equations. On your equations, you should have force friction is equal to coefficient of kinetic friction times normal force, right? You're like, ah, yeah, we got our friction force. No, we don't. We don't, guys. We don't. Do we? What's 55 cosine 35? We do. I lied. This is equal to 45 newtons. It's forces in newtons. All right. So we have our free body diagram, force normal, force gravity, force push Y. Got our force push F, which we already figured out. Speed, 45 newtons. Yeah, our force friction. All right, we're asked, what's the coefficient of kinetic friction on the floor? I just picked my nose on camera, so I'm sorry about that. I bet you ever saw that. I'm nasty. Okay, so force friction, as we found out previously, force friction, as we found out previously, is equal to 45 newtons. Because we concluded that they're equal to each other. .45 newtons is equal to our unknown times Fn. Our challenge is going to be to find Fn. Because we have two unknowns. Two unknowns right now are going to be coefficient and force normal, okay? So we basically have to go on a side quest. How to solve for Fn. To solve for Fn, we have to think about what's in the y directions. So you have two unknowns. So you gotta think in the y to solve for Fn. Okay, so I want you to think, look at this. Okay. Side quest. Side quest, guys. Let's solve the side quest. So if we want to solve for a force in the y direction, we have to think about the sum of forces in the y direction. You got to think, this is positive y, this is negative y. We add it up, add y. So we do Fn, what's on top, minus what's on the bottom. In this case, it's minus Fg minus F push y. F net y, remember, is equal to m times ax and ay. Since it's not moving up or down, remember, not moving up or down, moving this way, right? Or it's trying to move this way. Acceleration is going to be equal to 0 because it's constant velocity. So we have 0 is equal to Fn minus Fg minus F push y. So I want to get rid of my negatives. What I got to do is I got to add Fg, add F push y. If I do that, I get Fg plus F push, get spell y is equal to Fn. Okay, where I go from here? Fg, guys, know what Fg is. Fg is equal to m times g, mass times gravitational acceleration, gravitational constant. So 20 times, I'm going to simplify it. I'm going to use 10 meters per second squared. Okay. Actually, I'll just use 9.8 because that's what I have. Plus F push y, which we don't know yet. Yes, we do. Oh my gosh, we do know. F push y. Look, guys, look to the slide above. F push y. Look at that. F push y. Right here. Push y. 55 sine 35. 5 sine 35. Once you add them together, you'll get Fn. Okay. So that's not the final answer yet, because remember, we're still solving for a coefficient. Once you plug this all in, I think you get 227.55. Oh. What the? No, no. 227.55 newtons, okay? So that's normal force. We're kind of good. We're thinking about this, right? So force friction, keep solving. It's equal to 45. It's equal to unknown coefficient times 227.55. All you gotta do is just divide each side by 225, 227.55. And then you're gonna get a coefficient of a really small number. It should be a small number. And Cranmer coefficients have no units. Okay. That's your answer. Kind of messy there, but and go here after, okay, guys. Okay. On to the last question. I'll kind of want to die right now. I don't envy y'all taking the exam. I'd still rather take that exam than other exams, but to each their own, I suppose. It's 196-ish. So the last one's complicated. It's kind of a combination of what you learned in chapter 3, but now we're also adding in forces as well. So I'm going to end this meeting because we're definitely going to run out of time, okay? And then I'm going to record a new one.